and it can translate to any modality of data. And so what does that mean? You can go from text to text, right? Summarize a paragraph. You can go from text to text, translate from language to language. You can go from text to images, that's image generation. You can go from images to text, that's captioning. You can even go from amino acid sequences to protein structures. In the future, you'll go from protein to words. What does this protein do? Or give me an example of a protein that has these properties, identifying a drug target. And so you could just see that all of these problems are around the corner to be solved. You can go from words to video. Why can't you go from words to action tokens for a robot?
Mm-hmm.
From the computer's perspective, how is it any different? And so it opened up this universe of opportunities and universe of problems that we can go solve. And that gets us quite excited.
It feels like we are on the cusp of this truly enormous change. When I think about the next 10 years, unlike the last 10 years, I know we've gone through a lot of change already, but I don't think I can predict anymore how I will be using the technology that is currently being developed.
That's exactly right. I think the reason why you feel that way is the last 10 years was really about the science of AI. The next 10 years, we're going to have plenty of science of AI, but the next 10 years is going to be the application science of AI, the fundamental science versus the application science. And so the applied research, the application side of AI now becomes, how can I apply AI to digital biology? How can I apply AI to climate technology? How can I apply AI to agriculture, the fishery, to robotics, to transportation, optimizing logistics? How can I apply AI to, teaching? How do I apply AI to, podcasting, right? And so
I'd love to choose a couple of those to help people see how this fundamental change in computing that we've been talking about is actually going to change their experience of their lives, how they're actually going to use technology that is based on everything we just talked about. One of the things that I've now heard you talk a lot about and I have a particular interest in is physical AI. Or in other words, robots.
My friends.
Meaning humanoid robots, but also robots like self-driving cars and smart buildings or autonomous warehouses or autonomous lawnmowers or more. From what I understand, we might be about to see a huge leap in what all of these robots are capable of, because we're changing how we train them. Up until recently, you've either had to train your robot in the real world, where it could get damaged or wear down, or you could get data from fairly limited sources like humans in motion capture suits. But that means that robots aren't getting as many examples as they'd need to learn more quickly. But now, we're starting to train robots in digital worlds, which means way more repetitions a day, way more conditions, learning way faster. So we could be in a big bang moment for robots right now. And NVIDIA is building tools to make that happen. You have Omniverse, and my understanding is this is 3D worlds that help train robotic systems so that they don't need to train in the physical world.
That's exactly right.
You just announced Cosmos, which is ways to make that 3D universe much more realistic. So you can get all kinds of different, if we're training something on this table, many different kinds of lighting on the table, many different times of day, many different, experiences for the robot to go through so that it can get even more out of Omniverse. As a kid who grew up loving data on Star Trek, Isaac Asimov's books, and just dreaming about a future with robots, how do we get from the robots that we have now to the future world that you see of robotics?
Yeah. Let me use language models, maybe ChatGPT, as a reference for understanding Omniverse and Cosmos. And so first of all, when ChatGPT first came out, it was extraordinary, and it has the ability to do to basically from your prompt generate text. However, as amazing as it was, it has the tendency to hallucinate if it goes on too long, or if it pontificates about a topic it is not informed about, it'll still do a good job generating plausible answers. It just wasn't grounded into truth. And so people called it hallucination. And so the next generation, shortly, it had the ability to be conditioned by context. So you could upload your PDF, and now it's grounded by the PDF. The PDF becomes the ground truth. It could actually look up search, and then the search becomes its ground truth. And between that, it could reason about how to produce the answer that you're asking for. And so the first part is a generative AI, and the second part is ground truth. Okay, and so now let's come into the physical world, the world model. We need a foundation model, just like we need ChatGPT had a core foundation model. That was the breakthrough. In order for robotics to be smart about the physical world, it has to understand things like gravity, friction, inertia, geometric and spatial awareness. It has to understand that an object is sitting there even when I looked away. When I come back, it's still sitting there, object permanence. It has to understand cause and effect. If I tip it, it'll fall over. And so these kind of physical common sense, if you will, has to be captured or encoded into a world foundation model so that the AI has world common sense. Okay? And so somebody has to go create that, and that's what we did with Cosmos. We created a world language model. Just like ChatGPT was a language model, this is a world model. The second thing we have to go do is we have to do the same thing that we did with PDFs and context and grounding it with ground truth. And so the way we augment Cosmos with ground truth is with physical simulations. Because Omniverse uses physics simulation, which is based on principled solvers. The mathematics is Newtonian physics. It's the math we know. Okay, all of the fundamental laws of physics we've understood for a very long time, and it's captured into Omniverse. That's why Omniverse is a simulator. And using the simulator to ground or to condition Cosmos, we can now generate an infinite number of stories of the future, and they're grounded on physical truth. Just like between PDF or search plus ChatGPT, we can generate an infinite amount of interesting things, answer a whole bunch of interesting questions. The combination of Omniverse plus Cosmos, you could do that for the physical world.
So to illustrate this for the audience, if you had a robot in a factory and you wanted to make it learn every route that it could take, instead of manually going through all of those routes, which could take days and could be a lot of wear and tear on the robot, we're now able to simulate all of them digitally in a fraction of the time and in many different situations that the robot might face. It's dark, it's blocked, it's etc. So the robot is now learning much, much faster. It seems to me like the future might look very different than today.